Okay, yes, you can see. Let me go. Okay, Sheena, taken. Oh no, I hope you are feeling better. All right. Sheena says she's not feeling well. Okay, so take good care. Everyone drink more water. Right, because the weather is not very good recently. All right, let's start on light. Now, we have gone through all the light topics. We have revised the light concept, so we will not revise that again. All right, so but you have the whole full deck of slides to do your own revision. Okay, so for question 1, right, which statement about reflection is correct? So this is quite simple. So angle of incidence is equal to angle of reflection. So those easy ones, I will not spend too much time. Okay, so this is just the law of reflection. All right. So, but anyway, can you tell me what kind of reflection is shown in this picture? Can you type into the chat? What reflection is this? Let's see if anybody remembers it. What kind of reflection is this? Can I remember? You can see that at first the incoming light rays are all parallel. After they touch the surface, it all goes in different direction. All right, all goes in different direction. So what reflection is this? Nobody can, if you cannot remember, can you type that you cannot remember? At least I know. Good job, Unluck. Unluck is the only one who has given me the answer. The rest cannot remember. It's okay, just type cannot remember. Right, so it is irregular. Irregular reflection. Either that or you write diffused. Okay, diffuse reflection. Regular reflection will mean, it go up and then it goes also parallel. That would be regular reflection. Okay, let's move on. Concave mirror. Let me test y'all. I have a spoon here. I've been putting a spoon on my table since last week as a teaching aid. Now, can you tell me concave mirror, is it the inside of a spoon or outside of a spoon? Do you remember? Can you type in inside of a spoon or you can say front of the spoon or back of the spoon? Front or inside or outside? Okay, can you type into the chat? Concave. Okay, good job, everyone. Okay, so concave will be inside. All right, of the spoon, or you can say top lah of the spoon where the food is touching. Okay, food touching one. Okay, so that's concave. So you can tell yourself, food in a cave lah. The food, not, it's just a memory aid. Food in a cave. So the concave is, just use the word concave. The food is just telling you inside the spoon, the shape of it. That will be concave. Okay. So what is the important reason why the mirror must be concave? All right. So this one is because we want the light to be reflected as a parallel beam of light so that we can see far away, see the road far away. Hang on, let me admit one more student. Okay, welcome, Satika. Did I pronounce your name correctly, Satika? Hi, Satika, can you hear me? I'm Miss Ivy. Welcome to my class. Today is your first class. If you don't understand anything, type into the chat. Don't worry, alright, about giving me the wrong answer. We are doing last week's worksheet, which you did not join us, but never mind. That means you don't have the worksheet, but never mind. You will just read through the question. And then if you don't understand anything, put into the chat. I'll be happy to help you, all right, Satika? Okay, if I pronounce your name wrongly, please also let me know. Okay, let's continue. All right, so this is the topic on light. We actually revised all the concepts last week, but we didn't have time to go through the questions, so we are continuing with light today. Hang on, let me go back to my slides. Okay, right, so for a headlight for car headlight, The reason why it must be using a concave mirror and not convex mirror, concave mirror is for the car headlight, is because we want to have a parallel beam of light so that we can see the road far away. So this is what it means. So this is the headlights of a car, right? So there is a concave mirror inside. So inside there's the concave mirror, inside there's a concave mirror. There's also one light bulb inside, one light bulb inside. So this is a light bulb, all right? And this is a concave mirror. So the light from the light bulb will shine onto the concave mirror. And then this concave mirror will reflect the light as a parallel beam. So you notice that it's a parallel beam of light produced so that the driver can see the car, the driver can see the road far, far away. All right, is everybody clear? Okay, let me double check. Oh, there's one more person. Let me admit the person. All right, let's move on to the next question. Okay, just let me mark attendance for Zixuan, sorry. I thought I marked Zixuan. Your internet got probably not stable. Okay, no worries. All right, now this question 3. Now you have a ray of light traveling horizontally, like that, horizontally. When incident means coming in, all right? The light ray is coming in. Incident on a mirror, this mirror is tilted 30 degrees from the horizontal. So this is the mirror. You can see the mirror when you write the slanted line, all right? Like shading, there's a shading. That means this is the mirror. This mirror is put at a 30 degrees from the horizontal. This is a horizontal line like the floor. So this is the floor. 30 degrees up, this is how I put the mirror. Okay, so if I were to highlight the mirror will be, this is the mirror. Right, then the light beam is now coming in. And then the light beam touches the mirror and it gets reflected. Right, so they're asking you how to find this angle. Now you do your mathematics, right? Do you see this horizontal line, slanted line, horizontal line? That's a capital Z. Do you see a capital Z? If this is 30 degrees, do you agree with me that this is 30 degrees? All right, so alternate angles are, this is like doing mathematics. Horizontal, slant, horizontal. This line is parallel to this line. All right, this line parallel to this line. So if this is 30 degrees, this will be 30 degrees. So let me write here 30 degrees. All right, and if this is 30 degrees, this will also be 30 degrees because angle of incidence, okay, because there's a normal here. I'm going to draw the normal using dotted line. This is the mirror. Mirror and normal will make a right angle. So maybe I use green. Okay, so this is the normal. Okay, so it will make a right angle here. All right, so mirror is horizontal, normal is vertical, is a right angle here. Let me double check. Okay, no one in the waiting room. All right, so because of that, this angle of incidence equals to the angle of reflection. Okay, so let me maybe use a highlighter. I highlight as let me see. I shall use orange then. This angle and this angle must be the same. The two orange angles must be the same. And I call this, okay, angle of incidence. All right, and it's this one. And then this angle, I call it angle of reflection. So from the law of reflection, right, these two orange angle must be the same. So angle of incidence equals to angle of reflection. So because of that, this is 30 degrees. This has to be 30 degrees. All right, so this whole thing is going to be a big angle of 180 because it's horizontal line. I mean, take it as a straight line. This is a straight line. 180 degrees minus 30, then divide by 2. That's how I can get angle Z. Angle Z is this angle. All right, so let me write the steps down. So 180 degrees minus 30 degrees minus another 30 degrees. Then I divide by 2. So I will have 60 degrees. Hang on. 120 there. 120, right? Did I make a careless mistake? So this will be 60 degrees. Question 3. The angle Z. Oh, I see. I know why I got confused. I was looking wrongly. I thought my orange angle is Z. Now Z is this whole thing. Okay, I better highlight. All right, this whole thing is Z. So I don't have to divide by 2 already. So I don't have to divide by 2 already. So let me maybe highlight the angle Z so that you won't get confused at what I was doing just now. Maybe I will highlight it with a dark green angle, this one. This is angle Z. Okay. Maybe I'll remove the right angle, otherwise you get confused. Okay, so the green angle, so here I don't need to divide by 2 already. All right. So I will use 180 because I want to find this Z, this whole thing. So this is 30, this is 30. The reason why I know these two angles are the same is because the angle of incidence equals to angle of reflection. All right, this is the normal line, dotted line, normal line. All right, so I'll use 180 minus 30 minus 30. That's how I get the green angle. So the answer is 120 degrees, which is B. So this is angle Z. All right, any questions so far? If I'm going too fast, please let me know. Okay, question 4. Oh, someone is in the Satika, or maybe internet. Hi, Satika, your internet was not stable. Were you did you come out from the Zoom room, kick out accidentally, is it? I hope you can hear me now, Satika. Okay, let's go on to question 4. Okay, no one in the waiting room. Question 4, it says artificial light has adverse effects on wildlife. All right. So for example, migratory birds that fly in the night sky, they are quite poor thing, you know. All these birds that fly in the night sky, they will get disoriented by the lights of the lighthouses or by the lights in the city. So many of these affected birds will collide with tall structures such as buildings. So which is the best street lamp a country should adopt to minimize light pollution, so that the birds flying at night will not get disoriented by all the artificial lights from the lighthouse, artificial lights from the city lights? All right, so we basically want the angle that is the smallest. This is a little bit like common sense question. You can see the light beam. This is a light bulb, like the street lights. Then this is the angle, the light. This is the yellow light. Then if this is the design, your yellow light will be in this angle. If this is a street light, wow, your angle is very big. Or this one, if this is a straight light, your angle is 360 degrees, all angle. The light will go everywhere. All right. So this will be the worst. The best will be this because it gives you the narrowest angle. All right. So the answer is D. Okay. All right. Let's move on. Question 5. Okay. What color does a yellow object? This one is on light. What color does a yellow object appear to an observer under blue light? Okay, now first of all, if you have a, I don't want red. Hang on, blue then. I have a yellow object. The reason why my eye see as yellow is because it is, if I have, it only reflects what light? Can you type into the chat? Yellow object reflects what light into my eyes? My eye is here. Okay, my art is not very good. Y'all imagine it's a nice eye. Thank you, Harvard. The rest, can you tell me what is this answer here? A yellow object. Thank you, Zixuan. The yellow object will reflect what color light into my eyes.